Hi, so I'm Jason, and I've successfully influenced quite a few people to get this CG50, and I just thought I might as well shoot a video just for the couple of you guys who got a CG50, and I'll send it to you with this video of all the hacks and tips for the Excel A-level exam that I will be telling you on how to use it for the Pure 1 and Pure 2, as well as the statistical mechanics exam. And I thought this would be really useful because I've got loads of hacks and tips and tricks in regards to this calculator, and I thought it would be cool to share with you guys. Might as well, won't do anything bad. And I've asked someone out there for a little calculator hack when I got this calculator myself, but that particular individual didn't really give me a tour guide, so I thought this would be really useful for you guys. So, to get in exam mode, obviously make sure you have going to do everything in exam mode. So do 1, AC at the same time. Sorry, it's not turning on. 1, AC. Yep, and then we'll put it in exam mode by F1, F2, F1, and exit. So everything I'll be doing will be in exam mode, and I'll give you, so I've done the 2018 paper 1-2 and tell you what you can do with the exam in regards to checking your answers, as well as doing the questions and helping you see the graph. By far, the most important hack in regards is obviously the graphing function. However, I think the very clutch one to definitely know is to go into option and go to calc and solve. Solve basically solves any algebraic equation. So you could do like 2x plus 5 and then do shift dot to get equal to get 5, and then we get the answer to that algebraic equation. But obviously that's a GCSE sort of level sort of formula. So one thing this is really useful in particular is actually, let me just get up a question. Give me 1 second. Is trigonometric equations like this, where you have to solve. So this is on 2018 paper 2. Now it does say solutions based entirely on graphical methods are unacceptable. So this is really for you to check answers. However, when you do the question, up to this stage here, you can actually just type into the calculator using the solve function and get the answers. So you do gotta show you're working, but you can straightly plug it into a calculator to get you. So you don't have to do the 2 pi minus pi plus thing on your calculator. Go there, jump straight into here. And so I'll solve this for sine x equals sec x within the range 0 and pi over 2. So make sure your calculator is in radians mode. If you want to change it to radians, do shift menu and scroll down, and you can turn to degrees and radians. Make sure you can do that very quickly. Also, one thing that I would recommend is use a 2 calculator workflow, 1 in radians and 1 in degrees, so you don't have to switch between the modes. I'll tell you more about the 2 calculator workflow soon, but let's do solve. So solve for sine x is this button, equals shift dot sec, so 1 over cos x. And then we wait for the calculator to load, and you gotta be patient about it. Press exit, and then you get all the solutions. In fact, we're in a really generous range. So we need the range 0 to pi over 2. So we literally just find 0 to pi over 2. We got pi over 12 and 5 pi over 12, which in fact is the answer. So this is incredible. You can do that with this equation as well. Obviously, you're going to make sure you convert into radians for this particular question. So that's the solve function, and that's number 1 thing that I would really want you guys all to know. So you're going to delete all this. Delete, press F2 and F1. there are particular, so I'm going to talk about menu 1 for now, which is the main calculation mode, and about the 2 calculator workflow. There's particular things that are actually quicker on the ClassWiz, in particular doing logarithmic things. So you want to actually have a base log, you have to do option calc and then log AB. So you see that's a lot of buttons just to do like log 5 of 12. Instead of here, you can just press this button. So I would recommend doing basic calculations like log on here. Accessing the NPR and NCR functions is also quicker on this calculator. So 2p5, sorry, that's impossible. 6p5, you can just use this. Whereas on here, you gotta go to option calc, option stat. Oh, it's not in there. Option prob, yeah, it's in probability. In addition, to get the absolute value, you have to go into numeric, and you got the absolute value here. The really cool thing that you might not get to use, but the lowest common multiple and the greatest common denominator is also here. So that came in clutch for one of my physics questions in regards to 2 pendulums swinging at the same time and finding the lowest common multiple between them. So you can just do, let's get rid of the modulus, the lowest common multiple of 5 and 12, and an output 60. So that will probably be useful for you guys though. So you can also go math and actually get log AB quicker here, but I still would recommend using this one. Now the math, this section you won't use because that's for matrices. Absolute values, you can also get quicker here. So actually you only need to press F4 to get log AB and absolute value. The derivative is really useful to check your answers for calculus question, which actually is on this calculator as well by pressing shift integral. However, on this one, you got the second derivative, which actually came in useful for a particular question. Now, let's go to the paper 2 and let's see what sort of questions that this is super useful in, especially the graph mode. So let's go into graph mode and I'll tell you all about it. So press menu 5 and you get into the graph mode. So I'm on 2018 paper 2. First thing straight away, state the range of G. Now, working out G, range of G is actually really hard. You need to think a lot about the actual graph. So you could just, for what I did, is I just put 2x plus 5 and x minus 3. Now, be careful here. There is a restricted domain. Yeah, so you could just sort of ignore this part of the domain. However, there is a way to restrict the domain in this graphing mode. So do comma and do shift plus to get a left square bracket and shift minus to get a right square bracket. The lower limit, put it in there, and the upper limit, so let's just do a really big number. And that's how you restrict the domain on the graph, and so it'll only print out that section that we've specified. So this is way easier to state the range, because range is the y values of the graph, basically. And so we can G-solve, or we can simply press F1 to trace, and that will give us the first point on the graph, which is 7.5. So basically the maximum range is 15 over 2 is 7.5. And you can tell by just zooming out of the graph by pressing minus. You can see there's an asymptote. So we can press S1 and sort of scroll to the right, and we can see that it's sort of tending towards 2. So there's an asymptote towards 2, so therefore the range is that. So that's really easy to work out for a range of a function, of any function of any kind. Now, part C, inverse of a domain of a function domain is simply just the range of the normal function. So you should know about that. So vectors, you can't really do much with this calculator, unfortunately. Now this, where you have to sketch a graph, is obviously really, really useful. Obviously, there's a really simple graph, just modulus of x plus 3. But if you don't want to think about it, it's really simple to plot. So again, I'll tell you how to plot. So this part 1 and part 2, especially here, 3 marks, it's free. It's given to you for free if you have a graphic calculator, because you literally don't have to think about anything. So so to plot a modulus, you go option, numeric, absolute. So we get x plus 3, and then let's draw that, and we basically have the graph. So if you want to go to default view window, you press F3 initial, and then that'll give you the default sort of view window in a 1-to-1 scale. So you can sort of see what the y-intercept is. Now, really, really useful. Again, obviously this gave me 4 marks, but I could just sketch the graph. Is the Gsolve mode. Always use the Gsolve mode because that gives you so many important functions. The root of a function, so for example, a quadratic is where it passes the x-axis and you can work it out. Maximum value of a function and minimum value, especially for cubic graphs, you can work out the max and min just by pressing these buttons, and I'll tell you what they are. Y-intercept, so in this case it will be 3, so I'll put it y equals 3. We also have the intersect between 2 lines. So if you plotted 2 lines, it'll give you the intersect. Y-calc and X-calc is basically you give the y value. So let's say you want a y value of 5, and it'll give you what x values give you the y value of 5, and you can use the arrows to swipe through the functions. And the last but not least is the area under the graph, which is really useful. So you press the integral between 2 and 5, gives you the area, gives you a visualization, and the area on the graph is there, which is cool. Now let's go back to the question here. Explain why for all real values of x. Now we could simply just plot the other graph, because from our mathematical thinking, so we'll go option, numeric, and then x plus 3. If we know the math, we can see, oh yeah, it actually plotted to that graph, yeah? What this means, this graph is always bigger or equal to that. So we can see from the graph that that line is always higher up to the red line or touching that line. So therefore it's always greater than equal to. So I just sketched it, set it, and I got 4 marks because of that. So this is, again, very, very useful. Sequences, unfortunately, you need to know how to do it. Newton-Raphson, you need to know how to do it. And again, another trig function here. So you can obviously plug that into the solveN function to output all the values, so you don't have to bother about doing the plus pi or minus pi or plus 180, etc. We've dealt with the trig functions. Again, modeling questions is super clutch with this. So let's delete these formulas. And after we actually solve the math, I want to check if the equation is correct into this modeling. So in this particular question, we have find a quadratic equation to this model. So we worked out a model. So let's plug it in to see if it is correct. So we got x minus 40. And let's press draw. You can see it's very zoomed in. So we got the model. Again, we can restrict the domain if we want, but that'll just waste our time. We can just sort of look at that part of the graph. And so we've been told that the maximum point is 2012. So is our equation correct? How do we do it? Well, we press F5 and max 20 and 12. So our equation is correct. Are the roots correct? Well, we can press F5 and roots. Got a 0 in there and E40 in there, so that's correct. So yeah, that's how you really do it. Really important, really cool to visualize the graph. However, big no-no is to rely too much on this. The math exam is so time constrained, so I do recommend actually not using a two calculator workflow. Use this calculator as normal, go through the paper very quickly, as quick as you can, and then use the graphing calculator to check this sort of thing. So for example, checking this quadratic, if that's actually the graph that they printed on it. Do not get boggled down, because the 2 hours is not a lot for like 16, 17 questions. And the graphing calculator does take a long time to press the buttons and navigate the menus. So make sure you actually do the math first. And use a graphing calculator after you've done all the questions. Or for example, if you want to visualize a graph, quickly do it on the graphing calculator and then do the question. And then always come back and, for example, check the trig equations. For example, this, you can always check the trig equation using the solvent function. Now, so these differential equations, unfortunately, you have to do it. If you want to convert minutes into minutes and seconds, there's a quick time hack. So for example, this question, where we have to find the total time in minutes and seconds, and obviously we just plug it into the equation and we got 5.102 minutes. Now to convert quickly from minutes to seconds, you press the dot, this button above the ENG button, and it'll output 5 minutes, 6 seconds, 7.2 milliseconds. So we got 5 minutes, 6 seconds. So that's a hack on this calculator. Now for these partial fraction decomposition questions, obviously it's not this calculator exclusive, but there's one way to check if your partial fraction decomposition is correct, is by actually plotting the two simultaneously. Or you can plug in values to x and check if your partial fraction is correct. But if we plot in the left partial fraction, again, this is after you've gone through the whole paper. And unfortunately for this paper, I actually nearly ran out of time. So yeah, so you plug in that will plug in a graph. And obviously you got the A, B, and C. And what you do is you plot that. Plus minus 2, 1 minus 2x. And if you draw that, does that, you can see, right, I'll show you again. So the blue and the red should be exactly the same if your answer is correct, because they should be completely identical to each other. Red and blue are basically on top of each other. So that's how you know you got your answer correctly. This, prove f of x is a decreasing function. Now, if you see from the graph, when x is greater than 3, yeah? So x is greater than 3, so let's ignore this left part. You can see the graph is actually coming down graph, so the gradient's always negative. So you know for a fact, after you plot the graph in the graphing calculator, it's something to do with the gradient always being negative, and then you can just manipulate the numbers, differentiate, and prove that the f dash of x is always negative. Unfortunately, I got this question wrong because I didn't know how to prove it, but you just say that is always positive, that is always positive, therefore f dash of x is always negative. So that's that. Again, prove these sort of questions where you solve the equation, plug it into solvent to check if your answer is correct. That simple. And integration. So this, we can actually plot the graph. So we got 10 marks on working out the area, and if you want to know for a fact what your answer is correct or not, so this one, it didn't actually show what your answer is. So you could use the graphing menu, plot that graph, y equals x ln x, so y equals x ln x. So it actually plots the graph for me, and then we can actually find the roots. So we can desolve root. We've got root at 1 and root at 0. Now we need to find the area, so we need to find this area here. So we could check our area by doing G-solve, again, integral between 1 and E. So E, you have to do shift ln and go 1. And that outputs the non-exact area, unfortunately, because it's using numerical methods to calculate it. But our exact area is 1/4 E squared plus 1/4. So we could use E double calculator workflow, put in 1/4 E to E squared plus 1/4, compare the value, and it's exactly the same. So we know we got the area correct. So this is sort of the thing on how you check the areas. If you want to draw a normal, so again, we need to find the area of this line in this question. We could just simply go to trace, press trace, and put in the coordinates. So in this case, we have E, the x value, and then, the x value. So if we actually, so we actually go shift menu, and then here you can turn on the derivative function. So make sure you turn on derivative. So when you turn on derivative, you could go G-solve and, you go trace. And as you can see here, output what the gradient at that point is. So we want to find the gradient of E at x equals E. So we do trace and do shift ln to the 1. And we have the gradients 2. So we know the gradient at this point is 2. So therefore, the gradient of L must be -1/2. And then etc. etc. We can work out the coordinate at this point by finding gradient of that line and setting y equals 0. So this is a tough question. It's 10 marks, but you can definitely check and help you out by using a graphing calculator, because you can know the gradient at that point, find the area, etc. etc. You can also plot the line L as well by doing sketch normal, and we need to plot it at E as well. And we can plot the normal. So we basically have the 2 lines there. We can do G-solve, intersect. We could do G-solve roots as well. Unfortunately, this does not output the root of that. So unfortunately, you have to work out that manually using math. But that is what it is. To the statistic questions, go menu, and also you can plot a circle graph as well. So menu 9 lets you plot a circular graph here, and this came in useful for paper 1. So this as well, it's a trig function. You can plot in the graph and see what happens. So for example, here we got the graph, elliptical graph, and we could technically plot it here as well, but it might not be in that form, sorry, but there is a circle question somewhere like that. And let's say we got the circle equation, x minus 7. So -7 minus 5 and root 20. And we can draw a circle. Unfortunately, there's not much you can actually do. You could find the center of the circle, you could G-solve, and find a radius circle, x-intercept, and y-intercept. That's really it. You can't really find, plot another line and find the intersection, find the area, etc., etc. But center, radius, x-intercept, y-intercept are quite useful for you to visualize a graph if it's not given to you. For the equation solver, this is basically similar to the ones you have here by pressing menu A. So simultaneous equation, polynomials, important for solving quadratics, obviously. And for the binomial and normal distribution, you can press menu I, and it'll give you the normal distribution, which is extremely useful. So you plug in, for example, x value, your standard deviation, and your mean, and you can actually see what the area that gives you the output, the probability value for you, plot it for you, and you can sort of visualize the normal distribution very easily. Now, be careful though when you're using this p-value, make sure you always press Option and F1 here and see the full value, because that value is actually truncated. So sometimes you actually have to round up and you might not get the right answer. So always, if you're looking at the p-value in this mode, menu I, make sure you do Option F1 and see the full p-value from here. Now this cannot do the inverse normal. If you want to do the basic normal distribution, menus 2, distribution, and we got normal, and we got normal cumulative distribution, which is basically the same thing that you have put in variable mode, and you can put the lower, upper, standard deviation, and mean and output. It's basically the same as in menu 7 on this calculator, but in a nicer interface. So this is basically the same as this. The really useful thing here for stats is the binomial distribution, for cumulative binomial distribution. So if you look at menu 7 on the normal one, binomial cumulative distribution, variable, you can see that it only does probability of something, so the x less than a certain value. If we want to do the x is greater than a certain value, we've got to do the 1 minus whole shebang. On this, you don't have to. You can put in the lower, the upper. Let's say you have the binomial distribution modeled as 10, 0.5, and you want to find the probability of something greater and equal to 5. Well, we could literally put in 5, and the upper value is 10, number of trials as 10, and 0.5, and the output p-value. On this calculator, unfortunately, you have to do the 1 minus probability of x is less than 4. So on this calculator, it's a bit of a hassle, really. So you got to do 4, and then 10, 0.5, and then you got to jot down that value is 1 minus 0.362, blah, blah, blah. And then you got to go to menu 1, and then do that whole calculation shebang. And just to output really the same value. So this is really useful. Always remember it's the equals greater than equals something, but you can always put lower and upper on the binomial cumulative distribution. For regression, I recommend using this calculator. Menu 6, 1 variable, and use, for regression, it won't be 1 variable. It will be menu 6, 1 equals a plus bx, and put it in here. It's more convenient actually to do it in here than in here, because you've got to, if you want to do regression here, to find the product moment correlation coefficient, it's just more complicated. So I recommend doing it in this calculator. But anyway, very long video. I'll see you guys later.